Okay, this is 2.2, introduction to functions. First problem. Now, we're talking about the definition of a function, which I know we talked about in the notes. But what makes a function is just whether or not you have some kind of relation that takes some x values and does some manipulations to give you some different y values. Like you plug in 1, it multiplies each x term by 3 and divides by 2. Now, the thing you can't have, though, is you can't have a situation where you stick in one x value and you get out two different y values. That's not helpful. When you input one thing and you get out two things, that's not helpful. And that does not pass the vertical line test that we'll use to determine whether these are functions or not. And so that's the easiest way to remember it, is if a vertical line intersects the graph in more than one spot, it's not a function. Otherwise, it is a function. So here's a perfect example. A sideways parabola. It's not a function. The reason why is because if you stick in one x value, you get out like 1 positive 2 and 1 negative 2. You can't have that, right? You can't stick in one x value and get out two different y values. It doesn't pass the vertical line test, therefore it's not a function. Now, Desmos is really handy for these because you can type them in. So the first one, you can type this right in, just like it is, and you can see the function right away without having to solve for y. And this one does pass the vertical line test. The vertical line never intersects it in more than one spot. I know it looks like it does right here, but that's not a vertical line. It's got a really steep slope, but it's not vertical. So this is a function. Now, if you graph it, if you solve for y, it would look like this. It'd be the cube root of 1 plus x, where 1/3 is really the cube root. So that's the same, way to graph it. We used to have to solve for y and plug it into our graphing calculator, but Desmos allows us to just plug in a relation like this, and it'll graph that as well. So that's kind of handy. So the first one is a function, so that's all we need to say. Y, actually just, yes or no. All right, the next one is a function as well, because if we solve this for y, we end up getting, y equals negative x squared. You need to divide by 5 as well. But we know that's just a parabola that opens down, right? So y equals x squared is just a parabola, so that's a function. The next one is a function as well. I just graphed that in Desmos real quick. It does pass the vertical line test. You could solve for y as well, but that does pass the vertical line test. Now the next one's not a function because if you solve for y, you get y equals the square plus or minus the square root of x plus 6. And when you graph the positive square root, you get this function right here. But when you graph the negative one, you get this one. So when you go ahead and graph this, it doesn't pass the vertical line test. So that's not a function. Okay, only one of these is a function for the next problem, and it's A, because the rest of them don't pass the vertical line test. They violate. This one always passes the vertical line test. And like we said, you can't have one x value with two different y values, which violates the definition of a function. And basically you can remember it like this too. It's not helpful to have a situation where you plug in one number and it gives you two answers. That doesn't predict anything of value. We want to plug in like time equals 3 seconds and we want to get out a distance for, that corresponds with that time that an object is, for example. It doesn't make any sense when you plug in a time and you get out two different distances. That's not helpful. Looks like I accidentally put the problem on here twice, so be C for the next one. All right, so if we want to multiply by 14, that'd be 14x, and then add 15. There's the rule that would describe that. Pretty simple. All right, the next problem, we need to talk about domain. Now, this is a tough problem to get the domain from, but basically what we have is we have some things we can't have in math. There's two things we can't have in math. We cannot have a 0 in the bottom of a fraction. And we also can't have negatives under square roots, under even roots. That's important. Can't have negatives under even roots. So those are the two things that we really can't have in math. Zeros in the bottom of fractions, because that's undefined, and negatives underneath even roots, because that's an imaginary number. So let's look at the bottom here. 1 minus x squared. Basically what happens is that has to be positive. It can't be greater than or equal to because we can't have it be 0. It has to be strictly positive. So that's going to be our domain. I'm going to subtract 1 from both sides, so I get this. I'm going to divide by -1, so I get x squared is less than 1. Now, this is the tricky part. When I square root both sides, I get x has to be less than 1, or x has to be greater than -1, because when you square root both sides, you have to do plus or minus. Well, when you do the minus, you have to switch the sense of the inequality. So when I graph the domain on a number line, I can have all the numbers that are less than 1 and all the numbers that are greater than -1. So apparently this thing's only defined for these values right here in the middle, not -1 and 1. So it's only defined in the middle, right there, from -1 to 1. That's the domain. Now that's tricky. It says, is 1 in the domain? Well, no, 1's not in the domain, because 1 gives you a 0 in the bottom, which is undefined. So that'd be false. All negative real numbers are in the domain. That's not true. We know that -2 is not in the domain, right? It's only these values, so that's false. F of x is never 0. Well, that's not true. This thing can be 0. I'm sorry, f of x is y. So it's saying the y value is never 0. And I don't know how you get a 0 out of this for the y value. You know, a y value of 0 means that's where x is 0. I'm sorry, that's where y is 0. So if you plug in 0 for y and you try to solve this, I don't think you'll get an answer there. So if you're not sure, you can always look at the graph. The graph of this thing never touches the x-axis, so y is never 0. 0 is not in the range, so to speak. So that's true. The y value is never 0. All positive real numbers are in the domain? No, that's not true. Only from 0 to 1, not including 1, are the positive numbers that are in there. So that's false. 0's in the domain? Yeah, you can stick in 0. You just get the square root of 1, which is 1 in the bottom. Right? So 0's in the domain. F of x is never positive. That's not true. The y value, f of x, is positive. You know, all these values are positive. Right? So most of the time, in fact, it's always positive. No matter what number you stick in for the domain, you always get a positive y value. So that's false. And then the y value is negative. That's true. The y value is never negative. If you look at the graph, the y value never goes negative. So my domain is from -1 to 1, and my range goes from 1 to positive infinity. Now in the future, I'll ask you to write that. I'll ask you to give me the domain of this. The domain of this function is from -1 to 1, not including -1 or 1. And my range is, if you get this right from the graph, it's from 1 to positive infinity. So I'd say from 1 to positive infinity, and I can include 1 in the range. So there's my domain and range that help me answer all these questions. And we will do problems like this. I know it's a tough one, but it's good practice. All right, so the next problem is problem 6. It gives us this rational function right here. Now we know there's no square roots to look out for, but we do have to look out for is the bottom can't be 0. So let's find out where the bottom is 0, because that's a problem for us. So we're going to subtract 4 from both sides and get rid of the negative by multiplying through by -1, and then square root both sides. So we have issue at plus or minus 2. Those are problems that we can't have. Those are numbers we can't have, because if we stick in plus or minus 2, we get a 0 in the bottom, which is undefined. And that's an issue. Okay. So now let's look at the range of this function. So here's the graph of this function. If you're looking at the range, you can see the range is all real numbers except for these values between -1 and 0. All right, we're going to talk about horizontal asymptote soon, but there is a horizontal asymptote at -1. So it is undefined in these values for the range. So that's what we would say for the range. The range is a set of all real numbers except those in the interval from -1 to 0. And let's see what kind of brackets do we want here. I would actually use a bracket here. If you look at the graph, you can see that that we can't. -1 is a place where the function's undefined. So that means when I'm answering the question, instead of all real numbers except those in the interval, I can put a bracket here and a parenthesis here, because this is undefined in the function -1. So I can include that in my places where I'm saying except. And then I can't include 0 though, because that's fine. When you plug in 0 for this function, you just get 0. That's actually on the graph right here. So that can't be in my interval that I'm saying except. All right, the next problem then wants us to find the domain and range of this function. To find the domain, we know that what's underneath this radical has to be greater than or equal to 0, because we can't have negatives underneath square roots. So that's how we're going to find the domain. We've got to solve this inequality. Let's try to do it algebraically. Let's see. If I factor out an x, I can make a sign chart, like we've done in the past. I'm going to put the key points on there, which is 0 and 4. And I'm going to test to see if behind 0, -1 gives me a negative, and then a positive, so that'd be a negative. If I stick a number between 0 and 4, like 1, it gives me a positive and a positive. And if I stick a number bigger than 4, like 5, that gives me a positive and a negative, so that would be negative. So I'm answering, when is this thing greater than or equal to 0? It's greater than or equal to 0 in here. And I can include 4 because that's where it's equal to 0, and I can include 0. So basically, I can't have 0 to 4 because, 0 to 4 is my domain because that's what gives me positive values or equal to 0. So my domain is from 0 to 4, and I can include 0 and 4 in my domain because those just give me 0. Does that make sense to anyone? If anyone's listening, maybe not. Okay, that's fine. You don't have to listen right now. All right, if you graph this function, you can see the range just goes from 0 to 2. Okay, so we're going to go from 0 to 2. And we can include those points into our range because they are defined on the function. And I won't make you do this by hand, but you could find the range by hand as well because if you plug in 0, you get the smallest possible value for the function, which is 0. And then you know this thing's positive, so you know the y values that you get out are going to have to be positive. So you know it only goes bigger. Well, where's the biggest point? You can look at the maximum of this parabola, basically. You can look at where 4x minus x squared is the biggest, because that's when, obviously, y is the biggest. And it turns out that it's the biggest at 2, if you do the second calculate maximum for that parabola. So it goes from 0 to 2. You can obviously see that right in the graph as well.